Okay, everybody, let's recap the lesson. We're on page 484, but first I did a little bit of pre-teaching, so let's go back to absolute values. We know if we were to graph absolute value of x, it's just that v here in red. And then if I want to graph the line y equals 3, I did that. So I graphed them both together, my absolute value graph and y equals 3. So then if we were to take a look at this as a math problem, say, okay, absolute value of x equals 3, we're looking for the x values. So they intersect here, and they intersect here. So absolute value of x and 3 intersects here. So my x values are 3 and negative 3. But we knew that because we knew that if we just looked at the absolute value, if we put absolute value of 3 is 3, and the absolute value of negative 3 is also 3. So we know there is always going to be two answers, okay? So then we took a look at a little bit of a complicated one, and we graphed this one, okay? So we took a look at a 1/2 absolute value of x plus 2 minus 4, and that's this graph in blue. I went back 2 down 4. And then I said, okay, well, what about an equation y equals negative 2? So that would be here in red. So again, we have two answers. They intersect here at 2 and at 1, 2, 3, 4, 5, 6. So the two answers have to be x equals negative 6 and x equals 2. So then we thought, okay, well, let's make this interesting. So what if we had my absolute value of graph equal to negative 6? Well, negative 6 is way down here. It never intersects. So in this case, there's no solutions. What if we said, let's take our absolute value graph and set it equal to negative 4? If I graph negative 4, it intersects here. There's one answer, which is the x value of negative 2. Okay, so we could have as many as two answers, no solutions, or one answer. It depends on the problem. So then we took a look at the book. And we brought out the book, and we said, okay, well, we know that if we plugged in 5, we get 5. If we plugged in negative 5, we get negative 5. So we got rid of the graph. We just did the math. We know there has to be two answers. So then absolute value of x equals 2. We know that 2 is an answer and negative 2 is an answer. We just took away the graph, put it on the number line. There's my two answers. But absolute value of negative 3, we said was no solution. Graphically, it's below it, or we know this. Whatever goes in to an absolute value has to come out positive. It's impossible. So we said absolute values cannot equal negative numbers. We wrote that down. Absolute values cannot equal negative numbers, okay? So then we looked at 0. This time you only get one answer, and that's at 0, okay? Now, we said, okay, well, let's say these are my two answers, came from this equation, absolute value of x equals 1. If we looked at this two answers, we know that the answer would be an x, absolute value of x equals 4. So we can go backwards with it and recreate the equation. So then we looked at a story problem. We said, okay, well, if we're making baseballs, and we know that baseballs, if they're manufactured, we want them to be right around 145 grams. But they can be off. You're making a machine's making it, so you're going to have it be off a little bit. So we said, okay, what's acceptable? We can let it be off by as much as 3.295 grams, either direction. So we graphed my 145, and we showed how it could be a variation of that, okay? Then we graphed y equals 3.295, and we found out where they intersect, okay? So the intersect gives us the range that's acceptable. So we set up an equation. Absolute value of x minus 145.045 is the weight of the baseball. And we set it equal to the variation. And then we found out that we can add that much. So we can have it as high as 148. Or we could subtract that much, so at the lowest is about 141. And then we said, wait a minute. Let's see if this applies to some problems. We went all the way to number 3. We said, well, what's an easier way? We know there's two answers. So to get two answers, let's use two equations. So we took our absolute value of x plus 7, and we set it equal to a 3 and to a negative 3, because we knew there was two answers, so we got two equations. So, all right, we got rid of the absolute value. We set it equal to a 3 and to its negative 3, and we solved. We got two answers. We took a look at b. We need two answers, so we wrote two equations. X minus 9 equals 12, and x minus 9 equals negative 12. Plus 9 plus 9, I get 21. Plus 9 plus 9, I get negative 3, okay? Then we looked at C, and we were like, wait a minute. They're not supposed to equal negatives, so we said that obviously is no solution, okay? On D, because it equals 0, we only end up with one solution, and we got an answer of negative 3/2, okay? Okay, then we turn the page again. This time we looked at solving these kind of equations. No, if there's a number on the outside, we want to get rid of that first. Before we do the two equations, let's get rid of it. So we went minus 16, and then we did the two equations. Absolute value equals 16, and then negative 16. Okay. On B, same thing. Let's get rid of the extra numbers first. We went minus 6 first before I did my two equations. So then I did my two equations. I set it equal to 17 and equal to negative 17. Two equations. After I get rid of the 6, then I solved. Plus 8, plus 8, plus 8, plus 8. 25, negative 9. C, same thing. I've got numbers to get rid of, so I've got to get rid of the 3. So I divide by 3, set up my absolute value so I can get two equations, solve both equations so I get two answers. Okay. D, just a lot of things to get rid of. So first I got rid of the 10, plus 10 to get rid of the negative 10. Then I divide by 5, so I got it down just to the absolute value. So then I've got my absolute value of x plus 6 equals 9, so I wrote as two parts, positive 9 and negative 9, and I solved and I got those answers. Okay, so that's what I did for today. Homework was a worksheet, so if you need that, come see me. Okay, that's all I have.